Alright, so we're going to do two examples in which we're using our initial equation to find coordinate pairs, and we'll find those within these columns. Remember, because a coordinate pair looks something like that, where we always have the x value, which tells you how far to go left and right, and then a y value, which tells you how far to go up and down. And these are going to tell us those. So in order to start in this problem, we'll be using this equation, and we need to start with some x values. So the x values are located on the x-axis, and normally it's good to choose some that are closer to the center. So I like to go with -2, -1, 0, 1, and 2 pretty frequently. That makes it so you see what's happening right in the middle of the graph for many functions. So we can find the y value that goes with this x value, and so on through the rest of those. So we can do that by plugging it into this equation. Y equals, so we're going to figure out what y equals, x squared. Now our x value is -2. And we're squaring that -2. So when we square something, it's like we're multiplying it by itself. So -2 times -2 is +4, -2 is 2. So our first coordinate is -2, 2. And we can plot that on the graph by going left 2, so -2, and up 2. And that's going to be our first point at -2, 2. Alright, on to the next one. And you don't have to write y equals every time. We have -1 squared -2. So -1 times -1 is +1, -2 is -1. So we have a point at -1, -1, which means that we're going to go left 1 and down 1, and there's going to be another point right there. Alright, on to the third one. What's 0 squared? Well, that's 0 times 0, -2 is -2. So we have a point at 0, -2. So that 0 means that we're going left 0 and right 0, so we're just staying in the middle, and then we're going to go down 2. We have a point right there. Alright. Now we have 1 squared -2. 1 times 1 is 1, -2 is -1. So our next point is 1, -1. So we're going right 1 and down 1. We're going to have a point right there. And then we have 2 squared -2. 2 squared is 4, -2 is 2. So our last point, remember we were working on generating coordinate pairs, is the point 2, 2. So right 2, up 2, and our last point is right there. Now, this may look a little bit different than example 1, and that's because this is a quadratic equation. And so all that means is we have y equals x squared. So whenever we see that there's a 2 as an exponent, that means we have a quadratic. And when you get something like this, that tells you, or if you see this in the function, that tells you that we're either going to have a graph that looks like a U or like an upside down U. So now looking at the graph, it looks like we have a right side up U, like that one there. So we're going to go ahead and graph that like this. And you'll see these on and off as you go through algebra. So we went from an equation, we generated coordinate pairs, like in our first step, and then we found the graph. We were able to graph it all just from knowing the original equation. So let's try this with one more. And this is, the last one was a quadratic equation. This one is an absolute value equation. So what absolute value is it turns whatever is inside it positive. So if we put in a positive x value, the absolute value of 2 would equal positive 2, so it stays positive. For another example, if we had a negative 3 and we took the absolute value of negative 3, well, absolute value turns everything positive, so that's going to equal positive 3. Alright, so let's take our same values. Let's actually change it up a little bit just to show you that we can. Let's do negative 3, negative 1, 0, 1, 2. These are all, well, 0, 1, 3. These are also fine to do, and it still shows you what's happening in those 3 points, but then it's also going to show us a little bit wider out, which is always fine to do. So we have y equals the absolute value of negative 3 plus 3. So take a look down here. The absolute value of negative 3, it turns what's inside positive. So that turns to positive 3. Plus 3 is 6. So we have a point at negative 3, positive 6, which is right there. Now we're going to do absolute value of negative 1. What happens if we turn negative 1 positive? That goes to positive 1 plus 3 is 4. So we have a point at negative 1, positive 4, which is right there. Alright, absolute value of 0. 0 is different because it's not positive or negative, so we can't turn it positive or negative, it just stays the same. So the absolute value of 0 is 0. That's not LOL, that's absolute value of 0 is 0 plus 3, which is positive 3. So 0, 3. Alright, absolute value of 1 plus 3. Now look over here, if we take the absolute value of a positive number, it stays positive. So absolute value of 1 is 1, plus 3 is 4. And we have a point at 1, 4. And then last one, absolute value of 3, which is 3 plus 3 is 6. So we have a point at 3, 6. So you'll remember in the last video when we had something that looked like x squared, that was always either a u or an upside down u. Absolute value is actually pretty similar. The difference is that instead of a U shape, it's a V shape. So it's either like that, either going to look like that, or like this. Might see them in different ways, but when you see this in the equation, that means that we're going to have one of those two sorts of graphs. So this one doesn't really look like that. It looks like the one to the left of it. So we're going to go ahead and graph that. So it comes to a point there, and if I could draw a more perfect V, I would, but you're going to have to deal with that one. But it would be, it's going up, it's going right one and up one, right one, up one, right one, up one, right one, up one. So I didn't completely follow that perfectly, but that's what it would do. And that's what absolute value equations look like. So we saw quadratic, where it's shaped like a U, and we saw absolute value where it's shaped like a V. And at this point you should be ready for the homework problems. As always, make sure to ask questions.